Hello everyone, welcome back to our channel. Today we are going to continue our previous topic, which is message queue, and this is part 2 of it. So in previous video we talked about what is message queue, why we need message queue through a real example, which is user upload videos, right? So now in this video we are going to specifically talk about how we design such a message queue system, okay? To be more specific, we are going to talk about this part in our workflow, right? So how we design this message queue. Okay, cool. Okay, to clarify first, all our discussions in this video is based on the Kafka message queue, which is one of the most famous message queues in system design. Okay, cool. So, and if you are interested, you can go to this link, the official document link of Kafka, to learn more about it. Okay, so all our discussion is based on Kafka design. Okay, cool. So first, before we talk about design, let's talk about some basic or the most important concepts in Kafka. Okay, cool. The first one is called producer. Okay, cool. Producer. Okay, cool. So this is the first concept of message queue. So the producer is the service or the component which generates the new message and put it into the queue, right? So in our previous example here, you can see it's a video upload service who put the new video uploaded event into this message queue, right? So in this case, video upload service is one producer, right? So producer, okay, cool. And on the other hand, we also have the consumer, okay? So let's use this icon. We put it here, okay, cool. So this is called consumer. Okay, what is consumer? Consumer is a role or the service which pulls the new events which producer puts into the queue, into itself, and process it. So in our previous example, in the video upload example, okay, here you can see it's the violent content detection service and the cover photo generation service, which will pull the message or pull the event from the message queue and process the message relatedly, right? So this violent content detection service or cover photo generation service is a consumer for the new video uploaded event. Okay, cool. So this is a consumer. And of course, you can see between the producer and also the consumer, between them two, it's a message queue, right? And here we introduced another concept for message queue, which is a broker. So it's called a broker in Kafka, okay? Let's say this is called message queue broker. What is broker? Broker, you can just think broker is one machine. It's one node in our distributed system which holds the queue, right? So basically there is queues in this broker, okay? So here we have a queue, okay? So basically the workflow is like this. So basically the producer will put new events to the queue through in the message queue broker, right? And this consumer will pull the message or pull the new event from this message queue in this message queue broker, right? So this is how it works, right? And also you can see there could be all different kinds of event, right? So for example, we could have event which is called new video uploaded. Okay, we could also have an event which is okay, and maybe another event could be new comment on video, right? So there could be different kinds of events from different services which will put them into the message queue broker, right? So the different event is called topic in Kafka in the message queue, right? So this new video uploaded is called a topic. This cover photo generated is called a topic. Okay, so in Kafka, each topic or each new event, they will have their own separate queues. Okay, so for example, let's say we have these 4 events or we have these 4 topics in the system. Then we would have 4 different queues in the system corresponding to each topic individually. Okay, so this queue is for topic new video uploaded, and this queue is for topic new comment on video. This could be for topic payment accepted, and the last queue could be for cover photo generated. Okay, so this is called topic. Okay, so basically producer, message queue broker, consumer, and topic are the 4 most important concepts in Kafka message queue, okay, which is introduced in this documentation, and you can check it out. Okay, cool. Now let's see how this message queue broker works internally. Okay, so for now, let's consider how does the message queue work on a single broker, which means how message queue works on a single machine in our distributed system. Okay, cool. So now let's say this is the broker. Okay, cool. And now let's say one producer sends a request, which is, okay, now I need to put this new message to the queue, and the topic is new video uploaded, and there could be also a timestamp, right? So when this message is generated, so it's something like this, and also there could be some body, right? So for example, the video ID or some other things, right? So we don't care about body, right? Because it's very dependent on the topic, right? So, but basically for each new message which is sent to the broker, it has a topic and it has a timestamp, right? Cool. So how, when this server or when this node receives this new event or this new message, how does it store this message? Okay, because remember, we want the message queue be able to store the messages permanently, so no data will be lost when there is system failure or crashes, right? So how does it store it? So the way it stores is that for each topic, okay, there is a file. There is a file in the system which is stored on local disk on this machine, right? Okay, cool. So basically, let's say for this topic, new video uploaded. Okay, there is a file which is called new video uploaded. Okay, let's say this is a file on disk. It's a binary file on disk. Okay, so whenever the server receives a new video uploaded message, it will just append the message into the end of this new video uploaded file. So for example, maybe there's already some, okay, there is already some existing messages stored in this file. Okay, so it's like this. These are the existing ones. Okay, they are sequentially stored in this file already. Okay, now there is a new message. Okay, cool. Now let's say we accept the server receives this new message from a producer. Okay, then it just write this message as a binary data into the end of this new video uploaded file for this topic. So in future, whenever there is new message for new video uploaded sent to this server, the broker will just append all those new events to the end of the file. Okay, and you can see it's sequential write, right? So basically we only append new content into the end of the file, right? So it's a sequential write on the disk, right? So as we discussed in our previous video, which is a key value store on a single machine design, we already explained sequential write or sequential read has the best performance comparing to random read or random write, right? So maybe we can just discuss. Let's just briefly talk about why this is the truth. Okay, cool. So this is a hard disk. This is what an actual hard disk looks like, right? So you can see it's just like a plate, right? So and it will rotate. So this disk will continuously rotate, right? And also there is a header of IO header here. So basically the disk, we can read or write data from the place on the disk where the head is. So for example, here you can see the head of the disk is, the IO head is here, right? So here it touches the disk. So it means we can read or write to this place at this time on the disk. Okay, so we can only read and write data to the place on the disk where the header is located. Okay, cool. So now let's say the header is here. Okay, but let's say the data we want to read is here. It's on the edge of the disk. Okay, so in order to get the data here, the head must seek to this position. Okay, so basically it means, okay, the head will move first. It will move its head vertically to this position. Okay, and then so first the head will move to maybe this position, which has the same radius with this data. Okay, so it moved to here, and then the disk will rotate, right? So and then the head can locate this data, and then we can read the data from here. So basically you can see there are two movements, right? First, the head must move to the same radius, to the location which has the same radius with this data. So it moves here. Okay, let's say move here. And then the disk rotate, right? And when the disk rotate, this data will be under the head, which may be currently in this location, and then we can read the data, right? So basically the most time consuming part is the head must move from this location, which has this radius, to this location, which has a larger radius. So whenever the head moves, it takes a longer time, right? And on the other hand, the rotation of the disk doesn't take that much time. Okay, cool. So this, let's say we have random read and write, okay, which is the data is positioned like this. You can see most of the time we will just move the head of the IO head of the disk, right? So when we move the head, it consumes a lot of time. So, however, let's say if the data, they are adjacent to each other. Okay, so let's say the data, they have the same radius on the disk, and they are very close to each other. They are just next to each other. Okay, so in this case, if the head is here currently, in order to read the data on this orange place, we just need to rotate the disk, right? There's no need to move this head, because when the disk rotates, the head can be positioned on this location, and then we can read the data, right? And as we said, disk rotation doesn't take that much time. maybe it's 100 times faster than moving the head, right? So with this, if the data that we want to read or write are very close to each other, then the I/O could be very fast, and it could be, sometimes it could be the same performance with reading and writing to your memory on your system. Okay, cool. And this kind of read write is called sequential read and sequential write. Okay, and let's go back to the Kafka message queue. You can see for the new video uploaded events, all the events which is new video uploaded, whenever the server receives a new event, it just write the data to the end of the file for this topic, right? And since it's always at the end of the file, we are always writing to adjacent place on the disk, right? And this is called sequential write and sequential read. And in this case, basically most of the time we don't need to move the head of the disk, right? And with this, we have a very, very good performance, right? And also that's why Kafka message queue is famous for its low latency and high throughput. Okay, cool. Now let's remove this. Okay, cool. Okay, so this is the write path. Okay, and also similarly for the consumer. Okay, so let's say the consumer, one of the consumers now, let's say it's consuming this data. It's consuming this message now, and after it consumes this message, okay, so we can just read the data next to it, right? The next data, right? And which means it's also sequential I/O, right? It's sequential read, so it also has a very good performance, right? Okay, let's see. This is the consumer. Okay, cool. And similarly, after it processes this event, okay, and when it sends a new request to the broker to read the next available event of new video uploaded, then it just move to next one and read this data. And since this data is just adjacent to this previous data it read, it's sequential I/O, so it just get this data back very quickly. Okay, so this is how it works for this broker internally. Okay, and for this consumer workflow, let's have more explanation. Okay, so basically the first step, let's say for this consumer, at first it will point to this very first message. We call this as an offset. Okay, so let's say the data has index. Okay, so this data is 0, this data is index is 1, and this data's index is called 2. Okay, so they are increasing, right, whenever there's a new message. Okay, and for each consumer for this topic, there is an offset on the broker for this consumer. So per consumer per topic, there is an offset. Okay, so let's say for this consumer, currently the offset is 0. So this consumer, when this consumer send a request to read the data, to read the next available message to process, because the current offset is 0, so we just return this data to this consumer. Okay, cool. And after, so this, let's say this request is called get message. Okay, and after this consumer gets this message and processes it, it will send another request. Okay, to the broker. Okay, and this request is called commit. So basically it sends another request which is called commit. So basically commit, whenever this broker receives a commit message, it will move the offset to the next record. So the current, now the offset is 1. Okay, let's maybe use a different color. So this is offset. Okay, and then when the consumer sends the next request get message request, it will read data from here. And after it, the consumer processes this record, and then it sends another commit request. So the offset will be changed to 2, okay? So this is how it works. So there is an offset for each consumer per topic in the broker, okay? Cool. So this is how it works. Okay, and in practice, it's actually not only one file which we always append data to, it's multiple file, because we could have a limit or threshold to this file, right? So we could have a maximum size of one file, or we could have a threshold which is maximum records which can be stored in a single file, right? Okay, so basically, let's say whenever this file stores, let's say 10K records, then we will just create a new file, okay? Which accepts new messages from producer, okay? So this is a new file. So this file will be named as new video uploaded, let's say 0, okay? So this is the file name, and this new file could be called 10K and 1, because the starting index, the starting offset for the new record will be this 10K and 1, okay? Cool. And similarly, we could have more files when we have more messages, and as it achieves the maximum size and maximum records for a single file. Okay, so each file is called a segment, okay? It's called segment file, okay? Cool. And also, for fast search, okay? So for example, we know when the SIM system starts, okay? So we know that for consumer, let's say for consumer X, the current offset is at maybe, let's say, the current offset for the consumer X is, let's remove this segment, okay? Is at 8,000, okay? So we need to know we need to locate where is a record of 8,000 is on this segment file, right? So one way you can do this, you read the whole content of this segment file and begin your loop through the first one, right? And then see which one is 8,000. So you know, okay, I need to read data from this location of the file. But this is low efficiency, right? So that's why for each segment file, we also have index file, okay? So basically, it's an index for this segment file. So what it looks like, it will be, you can think it as a hash map, okay? So basically it looks like this. The first record is the index 0, okay? So for index 0, it's at 0 byte of this file, okay? And the second record is, okay, what you could do is that you store all the offsets in this file, right? So you can see, okay, for record 1, it's actually at the 10 bytes of this file, okay? And for record 2, it's at the location which is maybe 30 bytes in this file, right? So you just read from the 30 bytes, okay? And you have it for all other offsets of this topic, right? However, you can see we store the index for all the files, which is still very low efficiency. First, it consumes a lot of space on this file, right? Second, in order to get the offset, you still have to read all the data from this file, right? So you still have to read all the keys and values for all the offsets, which is from 0 to maybe 100K, okay? So you have to still have to read so many data, right? And you still have to scan the file. So what we could do is we could take some samples, right? So basically, yes, for the first record, we store, okay, the location is 0, But for the next one, we just store, okay, for 100, for the 100th record, the offset in this, the byte offset in this file is actually, let's say it's 800, okay? And the next one is 200, okay? And we know it's 1000, okay? Maybe, okay? And for 2000, it's 3000. And for 100K or 10K, the offset is this, okay, in this file. So when the system starts, we just read this whole index file into memory, and you can see it will not consume a lot of memory, right, or even disk data, because it's sampled index, right? So we read it into the memory, and then we can just, let's say the current offset for consumer X, which means consumer X needs to process the 8000 record from this file, right? So then we can just use binary search in memory to see, oh, actually this 8000, let's say we have a record here, okay? So which is 6000, okay? Okay, this 6000 data is actually stored between the 6000 and the 10K record, right? So we just need to read the data from the 6000, and we read until this byte. We read the byte in this file from 8000 byte and the 21st K bytes, right? We read the data from these two ranges and just scan this range, these bytes. So then we can easily get the 8000 records data easily, right? So with this, we don't need to scan the whole file to get this data, right? So that's how we use the index file for each second file to do the search efficiently, right? Okay, cool. In this video, we talked about the Kafka message queue design, okay? So we introduced 4 concepts, okay? Producer, consumer, message queue broker, and topic. And then we talked about how a single broker store the producer's new message into the file system, and how the consumer reads the next available message from the broker, right? It's also from the same file. And we also talk about both the read and write from producer and the consumer do the sequential read and write, and it has a best performance, and that's why Kafka can achieve very, very high throughput and very low latency, okay? And we also talked about how to use index file to do fast search within the segment file, within the topic file, right? So, and the purpose is to efficiently and fastly locate the location of data in this huge segment file. Okay, cool. So hopefully you enjoy this video, and this is part 2 of message queue design. So in next video, we are going to talk about part 3 of message queue, which is how the message queue work in a distributed system, which means how the message queue with multiple brokers. Okay, thank you. So if you like this video, please like it and also subscribe to our video channel. Thank you. Bye bye.